Question number 1, December 2022, engineering graphics paper from the University of Mumbai. And here we go. Let's check this out. So we have been given the pictorial representation of an object, and what we need to do, we need to create the front, right hand side and the top view. But the front view is slightly different. It is a sectional front view. So you need to cut the object along this line, this section AA. Okay. One more thing. I have made a virtual model in AutoCAD. Let me show that to you. This is how the object looks, and to basically check out the features, we'll be rotating the object. Even we'll be cutting the object, slicing the object, and then we are going to prepare the sectional front views. Okay, but how to do this manually, I'll be demonstrating all of that. Don't worry. I think we can now shift to the question. Here it is. Here we go. So the first thing is, there are four things which have been asked in the question. Number 1 is the sectional front view along the section AA. If you take a careful look, this line is where you need to slice the object into 2 equal halves. You have to go for a full section, as the section starts here and ends here. So the entire object will be cut, the front portion will be removed, and then whatever you see from over here, that is by default your sectional front view. Whatever you see from the top qualifies as the top view. Whatever you see from the right hand side qualifies as the right hand side view. And also you need to insert some dimensions. Please note that all the 4 things which have been asked in the question have some marks associated: 5, 4, 4 and 2. If you add all of them, this constitutes 15 marks. So 15 marks can be fetched out of 60 directly from this one single problem. It is a bit typical, but I'm sure in the next 15 to 20 minutes we can crack this very, very easily. Here we go. Shall we begin? Okay, here we go. First of all, I want all of you to take a look at this 3D arrangement. Take a look at all the features. Can I pause this? Okay, if you observe carefully, this portion looks like a cylindrical tube, okay, hollow from inside, having an inner radius and an outer radius. All the dimensions have been given, don't worry. This portion ahead of this profile in front is of 8 millimeters, whereas this portion at the back is 18 millimeters. So there is a difference. Initially, when I was creating the CAD model, I actually assumed that the portion over here is 18, so in front also it has got to be 18, but that is not the case. The tube is a bit eccentric, so please remember, don't commit the same mistake that I did. Okay, let me resume this. Keep watching. What we'll do now is we are going to have a cutting plane, popularly known as a section plane, and let me get the section plane passing through the center. Exactly. What you see over here, the portion of the object which has come into contact with the section plane is what is known as a section. This grayish portion is what is known as the section, and you need to draw the section from watching the object from over here. Okay, this is your front on, right, as far as the problem description is concerned. So front, the section can be seen, and hence we call this a sectional front view. Let me resume the video. Take a look again. This basically is going to be your sectional front view. Okay, I think it would be better if we can just take a picture of the sectional front view. Let's take a picture of the sectional front view, and let me take you to the next slide. Now we need to determine the maximum length, the maximum width, and the maximum height of the object. For that, let me take you to this figure. Listen to whatever I say very, very carefully. This is going to be very important because we are going to be following the box approach. Okay, so here, in fact, in any problem, you have a front view, you have a top view. Over to the right of front view, you have the left hand side view. Please note this. And over to the left of front view, you have the right hand side view. What do we need to make, sir? We need to make the section front view, the top view, and the right hand side view. So this is going to be our approach layout. This is going to be our layout. I hope you guys understand this very, very well. Okay, if you were supposed to draw the left hand side view, then our layout would have been this, right? I hope you understand this. What is the maximum width Sir, this is the length, this is the width, and that's the height. Again, this is the length, width, and the height. Sir, the maximum width is 70. So this is very easy to determine. Second, what's the maximum length? Sir, maximum length is also very easy. If you watch, this distance is 40. This distance is 18. And in between, this distance is, radius is 15. So that's 15 to the left of the center, and that's 15 to the right of the center. This in fact is 30. 30 plus 40 is 70. 70 plus 18 is 88. So the length happens to be 88. We all need this. The width is 70. Sir, but what about the height? The height also can be determined very easily. Take a look. What is the exact vertical distance between the center? And if I call this the base plate, okay, the bottom of the base plate is here. This is the bottom of the base plate. From the center to the bottom of the base plate, it's 48. What about this? Sir, this is having a length of 18. The reason is very simple. This happens to be the radius also. So the diameter of the larger circle is 36. Therefore, the radius is going to be 18. Simple. Done. So far, as far as the height department is concerned, we know one thing, that it is going to be 18 plus this 48. What else? What else can you add to this? Sir, what we can do is, we need to add this much also. Should I zoom in? How can you find this out? Sir, actually this is 26. If we subtract 18 from it, this will be 28 minus 26 minus 18 is 8. So this is going to be 8. So plus 8. What's next? And if you watch this distance, the remaining, this is 15. So let me add 15 to it. You just need to add all of them, sum them up. 18 plus 48 plus 8 plus 15. This works out as 89. Okay, so there you go. The length is 88, width is 70, whereas the height is going to be 89. So now the approach is very clear. We need to start by making 3 zones. This zone is for the front view, and as I have told you before, that's the top view. Right hand side view is always to the left of front view. Okay, now what were the datas? Length is 88, height is 89, width is 70. So in the front, what you'll see is this length 88, height is 89. Done. This again is the length, which is 88. This in the top view, you see the width. Width, we worked it out as 70, as you can see. Once you have both of these boxes, you can make this right hand side view box very easily by simply extending these lines towards the left, and then these lines towards this partition line, and then rotating them at an angle of 45 degrees. Okay, and then producing them in the upward direction. The intersection, that's the intersection. These are the intersection. So these are the corner points of the box for the right hand side view. I hope this is clear to everyone. And by the way, this is the first question. It's typical. When I teach this subject in a very formal way, we go through all the concepts very, very carefully. If you want to learn from the basics, you must enroll in my course on my application, the engineering, drawing, engineering, graphics course. Does not matter which university of India you come from. This is going to benefit you a lot. And please remember, your first year of engineering is very, very important. If there is a backlog, there is a star on your mark sheet. That does not augur good for your future. Make sure you pass your engineering with no backlogs as such. And this subject, once they receive a backlog, I mean, you take it to the second semester, already there is a load of 5 to 6 subjects, and then plus 1 more, okay, or 2 more or 3 more. If there are backlogs, you won't have a good frame of mind. Positivity will get away from your life. And please note, I mean, let's say this. I am sure all of you would agree that backlogs create a very, very bad atmosphere, even amongst friends and families. Okay, so try to work this subject out, and this can be worked out very, very easily. It's not a difficult subject. Students make it difficult because they don't start learning from the basics. Once you do that, you'll start getting the results. Okay, and that's why I say, if you want to learn graphics, enroll in my course ASAP. Okay, let's resume. Now you know how all of these boxes can be created. What we want to do is, we want to start creating the front view. By the way, I'll initially create the front view, then I'll do the section. Okay, and that's what you call the section front view. This is the approach that I'll be following. It's a non-conventional approach, but I'm sure you'll understand. Okay, so how do we start? This is for the front, that is for the right hand side, this is for the top. How do we start? What you can do basically is try looking for this very point. Okay, so how do we know the exact location of this point? Sir, from the bottom it is at a height of 15, and from the leftmost corner, this is not the leftmost edge, the leftmost edge is this over here, that is 18 plus this is going to be 15. 18 plus 15 is 33. So if I were to give you the coordinates, it is going to be, this is 33, and from the bottom this is 15. I hope you can mark this point. And please, whenever you make these center lines are where you see a circular profile, please make a plus sign and then extend it to the east, west, the north and south, right, in the chain form. Done, sir. Now what? Now what you can do is, from this point over here, this is the point I'm talking about, that is the line 56, that is the line 56. Again, this line over here, this curved portion that you see will look like a vertical line from over here. Okay, this curved portion will rather look like a vertical line. The line's length is going to be 36, so this is going to be 36 in totality. 36. Done. That's 56, that's 36. You know this. Secondly, please keep this calculation inside your head. If the diameter of the outer circle is 36, what is the radius? Sir, it's 18. Okay, inner circle's radius, sir, the diameter is 18, therefore the radius is half, 9. So 18 minus 9, outer radius minus inner radius, will give you the thickness of this tube. R outer, if I were to calculate the R, outer radius, it is going to work out as 18. Inner radius is going to work out as 9. The thickness of the tube can be worked out as R outer minus R inner, which is going to be equal to 18 minus 9, which eventually will work out as 9 mm. So you can say this thickness over here is 9 and this thickness over here is 9. So 9 mm below and 9 mm above, you are going to make these sort of dashed lines. Why? Because this is an inner circle. Okay, it goes behind 56 millimeters, it goes behind 56 millimeters. That is why we have done this. So in order to show hidden features, what you can do is you make use of such dashed lines. Over and out. Clear to everyone? Then take a look at this point. Where is this point or this point? So right at the center. To be very precise, they are somewhere here. Okay, how do you find these points, sir? It's very simple. And one more thing I forgot to mention is this line. What is this length? Sir, this length is actually 18. This over here, this length is actually 8. So you can make these lines very easily. Okay, all the dimensions have been given. Now what you need to do is you need to drop 2 lines vertically in the downward direction. Sir, but again the problem is, what is this length? We can work out this length. Let me zoom into this. Zoom out slightly. Okay, from the center to the base of the plate, 48 minus the thickness of the plate. 48 minus 10 will give you 38, minus this 8, 30. So this distance, okay, right from the center line to the bottom, it is 30. So you need to travel this distance of 30. This is 30 and this has to work out as 30, right? This in totality is 56, out of which this much is 18, this much is 8, so 18, 8, 26, and this is 56. This is remaining. This has got to be, how much did I say? 30. Okay, very easy. Now how do we proceed now? Again, if you watch, Let me take you back. From here, go in the downward direction. This is 26. This again is 8. 8, not 18. This is 8. 26. 8. Now we are here. This is 40, sir. Go here. This is, sir, this is 10. Down. Then this, how much? Sir, 40 again. So we are almost done with the front view. Let me make a few more additions. Okay. Sir, this is 26. When you subtract 18 from it, the answer is 8. Okay. 26 minus 18 is 8. So this much distance over here is 8. So, or what you can do is simply make a vertical line through this point until it reaches the center line over here. And now you can see this arc is having a radius of 15. So with this as center, with this much as the radius, make an arc. Radius is 15. Done. Sir, this inner circle is having diameter of 15. So the radius is going to be 7.5. This is how you need to make it. Done. That's the front view. Not the section front view. We are yet to do the section. Right? I'm following a sort of unconventional approach. You can straight away start making the section front view. I rather want to show you what happens when you initially start with a front view. Then you see there are so many hidden features which have been represented by dashed lines. In order to get rid of that, what we do is a section, and then how beautifully you can see the inside of the entire machine component. That is the idea. Okay. So please don't mind. Now, what you are going to do is, these are the important points. Okay. And through them, you can draw lines, right? Like this and this, both horizontally and vertically. These are the projectors which will act as guidelines. Okay, they're going to help us create the top view as well as the right hand side view, both. There is one more thing which I would like to show you. This over here, this edge, again can't be seen directly from over here. It is hidden, therefore a dashed line. How far is this, sir? This is 15 plus 10. That means it is 25. Done. All right, let's finish this in the next 5 to 10 minutes, not more. Now let's make the top view, sir. Okay. Sir, this line over here is exactly at the center, like this, isn't it? Yes, sir, it is. What to do then? What we can do is we can make this center line. Okay. We can make this center line. Okay, done. Then, sir, we know we have to sort of make a rectangle over here. You see, this is 56, this is 36. So we can make this rectangle. This is 56, this is 36, isn't it? Okay. And that's the beauty. Again, this is the inner radius and its extension behind cannot be seen. Therefore, it is a hidden feature. I hope you guys can understand this very easily. What is the next thing that you are going to do? So the next thing is, if you watch, these are the points that we are interested in. What we are doing right now is we are making the top view. In the top view, these 2 points will be, please, I am referring to the front view also. These are the crucial points for me. Okay, these are the points that I am talking about. If I say this as 1, 2, this is 1, 2, this is 1, 2. Okay, and through them, what you can do is you can make these lines, just do it. Done. Okay, now just close it. This is what I made. Done. Okay, sir. Now what? Now you see again a hidden feature. Draw it. Done, sir. Now what? Now what you can do is, we are here. Okay, you go this way, and here also. How much is this? Sir, we can work it out. So do work it out. So this is 70, out of which this radius is 10. So this is 10 over to this side, to the right hand side, and to the left hand side. Make it 20. 70 minus 20 is 50. Half of 50 is 25 over here, and then 25 over here. Okay, please note, 25 plus this 20 is 45, plus 25 again, it is going to be 70. So that's 25. You reach here, and from here again you go in the upward direction, stop at 25. Now again the work is simple. This is 15. Can I zoom in? That's 15. Here it is. Mark the center. Now with a radius of 10 millimeters, make the arc, semicircular arc. Done. Easy. Top view is also done. Now what we will do is, you can make all the lines. It rather gets crowded. I am interested in the crucial ones. Rotate at an angle of 45 degrees, project it upwards, and now we can begin. Now we wish to see how the object looks from the right hand side. The first thing, the outlines from over here, bottommost, make it. Done, sir. This over here, this arc would look like a line, isn't it? A vertical line simply. This arc over here would look like a vertical line. So what you can do is this arc, I think this is the arc. Just watch. This is the arc. It would look like a line, and then there is a straight vertical line. So this is the arc and then a straight vertical line. So this projector over here will help you to stop right here and here. This is the reason we drew these guidelines. Done. Okay, sir. Secondly, what you can see, this thickness over here. How much is this thickness? This can be worked out. Again, you can take this as the reference. Okay, so make a hidden line, then a center line. Very easy. Both of these center lines are at the same level. You can now understand this. Then, sir, one more thing. If you watch, there has to be one more hidden line, a dashed line. Okay, corresponding to this, you've made a dashed line. So here also you should make a dashed line, but I haven't. The reason being very simple, not very simple rather. The reason is that the line thickness that I have given is 1.5. Okay, so try to listen this. What is happening over here, that there is an edge. There is an edge through this very point. That edge and the hidden line from over here, they are extremely close to each other. There is a difference of 0.5 millimeters only, right? So the thickness is actually gets overlapped with it. That is the reason. It is possible when you make it with pencil, these things may not happen. What I am trying to say essentially is that this solid line, and then there just 0.5 millimeters below, you are going to have a line like this. Okay, attached line. So you can see, you could see the difference. I'm not exactly sure, but yes, on my diagram it is not showing. Anyway, don't worry about it. Tension nahi lene ka. Let's move ahead. What is the next thing, sir, that we can do? The next thing is, from where are you watching, sir? From the right hand side. Where is this center? So here it is. You can extend this, and then we can make a line like this. This is going to be the exact location of the center, and here it is. Here it is. That's the center. And by the way, what about these lines, sir? What have we just done? We can make these boxes. These boxes are having a height of 10 millimeters. So 10 millimeter side. Give it some height. Done. And then locate the center. Through the center. Sir, this is having a radius of 9. Sir, this is having a radius of 18. Do it. Make these concentric circles. Done. Now the task is very easy. In the front. Okay. This is for the front. 1, 2. Let me write it like this. 1, 2. But when you look at it from over here, right hand side, this is going to be 1. Let me put a dash also. Double dash, 2, double dash. Can you understand? This one single point represents 2 points. One at the front, one at the back. Okay. So you need to come downwards 30 mm below. This distance we know very well, it is 30. So you can take this line as the reference. Okay. Come 30 down, then this way to the extreme left, this way, this way, this way, and then you can obviously close it down. And finally, as far as the section is concerned, let me talk about it. What we really want is the portion of the cutting plane. Cutting plane passes through this section line. Okay. So this tube is being cut into half. So when it is being cut into half, This is the portion which needs to be sectioned. Yes, sir. Agreed. This portion in the middle. Yes, agreed. Then this entire tube over here, okay, right to the back, it has the same cross section. So this also will come into the picture. When you take all of these things into account, you can make the hatching like this. And when you do the hatching, please note, please everybody note that these solid lines have to be removed, okay, because they were part of the front view. You are making the section view. Even these hidden lines, remove them. This is how the diagram would look finally. And want to see some magic? Let me bring this over to this side. Okay, before I show you the magic, please note that all the construction work should be done very, very lightly. This is how your work should look. And in fact, while making these hatching lines, make use of a pencil which sort of has a grayish tint or a grayish color. Keep it very light. 2H pencil, I would suggest you guys at an angle of 45 degrees. This is how the section looks. And finally, let me show you some magic. Okay, this is the pic that we took from AutoCAD, and it fits in perfectly with our own created drawing. Looking good. Okay, and we were also asked to show the dimensions, at least 10 dimensions. So here they are. The font size is a bit bigger so that you guys can look at these dimensions clearly. That is why I've kept a bigger font size. In examinations or whenever you are doing some manual drafting, keep it between 3 to 5 millimeters, not more. Okay, as far as the font size is concerned, this is what I'm talking about, font size, right? Yeah, that was the problem. Okay, I hope you have found this entire demonstration to be very, very helpful, efficient, and effective. Please share this video with all of your friends and classmates, and so that they can also benefit. And if you've got any doubt in engineering, drawing, or mechanics, do send your questions to me directly on my application through the chat box. Okay, don't hesitate to send questions. So don't worry. Thank you.